As you know, in Three.js we have a set of materials to choose from depending on the need. That said, one important factor that most materials share is their need for light to appear. Here, for example, I have 500 meshes that all use the mesh physical material, and you can clearly see how the light is affecting them. Now, let's say we want to dynamically colorize these meshes based on their positions on the canvas. To do that, we need to use a customized material, so I have the uniforms object containing the resolution and of course an instance of the shader material. And if we take a look at our shaders, you see that I have some very basic stuff here. So what I'm going to do is use the custom material that I made instead of the mesh physical material. And there we go, everything works fine. Well, not exactly, because as you see, we lost an important piece of information, which is how the spheres are responding to the scene's lights. And this leads me to the main topic of this video. When you use the shader material in Three.js, you actually lose a ton of information that you may need besides the shading, like metalness, roughness, reflection, etc. So how can we create our own custom materials while maintaining those important information? To do that, we have three options. The first is to do the calculations manually in the fragment shader. The second option consists of extending an existing material using the onBeforeCompile callback function to replace part of the GLSL code of the material. The third option is the same as the second one, except that we use a library, and this is exactly what we are going to do in this tutorial. Three Custom Shader Material is a fantastic library that makes this task so easy to achieve and with a way cleaner code base. So first and foremost, we need to install the library by typing this command in the command line: npm install 3-custom-shader-material. Next, I'm going to import it. By the way, you have to make sure you add /vanilla to the path if you're using the standard Three.js, not React 3 Fiber. Now, I'm simply going to create an instance of the custom shader material and set which material I want to extend using the base material property. As you can see, things work as intended. Furthermore, we can set the material properties like the color, maps, and every other property that belongs to the mesh physical material. Now let's try to do the example I tried earlier, so I'm going to set the fragment shader. And nothing has changed. One of the reasons behind that is that I used the resolution uniform without passing it from the JavaScript side, so let's do that. And again, we still don't get the result we want, and the problem here is that we are using the glFrag color as the output of the shader, which is how things need to be done if we don't use the library I'm using right now. So what I'm going to do is use the CSM diffuse color variable instead. This will ensure that we modify only the color of the material and keep all of the information like the shading. And there you have it. Now let's say we want to animate the vertices of the meshes using the vertex shader. I'm going to add the vertex shader to the custom shader material and of course set the time uniform. Nothing has changed because we also need a special variable in the vertex shader which is under the name of CSM position. And with that done, we come to the end of this tutorial, so make sure to like, share and subscribe, and I will see you in the next one.